Hello, today we've been asked to sketch the graphs of some polynomials. And this is something that we run into quite frequently in algebra, where we've got a function and we want to know what it looks like. And a couple of the things that you have to do if you sketch a graph of a polynomial is you have to know the zeros and you have to know the multiplicity of those zeros. You have to know the end behavior and you have to know the Y-intercept. So we're going to find each of those things: the zeros, the multiplicity, the Y-intercept, and the end behavior. So the first thing I start with is end behavior. I look at my polynomial. This is a fourth degree polynomial, and it is a positive leading coefficient. So the end behavior is going to be like this. It has to be up. Both ends have to be up. The second thing I need to find is the Y-intercept. Okay, so that's the first thing. The second thing is the Y-intercept. And this one's easy, because to find the Y-intercept, you set x equal to 0. So 0, 4 times 0 is 0. 3 times 0 is 0. So y equals 0. So the Y-intercept is at 0, 0. Okay, and then the third thing is you have to know the zeros and their multiplicities. Well, to know that, you have to factor this polynomial. So immediately I look and I have a greatest common factor, which is x squared. So if I factor out an x squared, what am I left with? X squared minus 4x plus 3. And then I ask, can I factor what's in those parentheses? Well, I can. And that gives me x squared times x minus 3 times x minus 1. Okay, now, last step here when you're factoring a polynomial is to set each factor equal to 0. So I have x minus 1 equals 0. Move that over, I get x equals 1. Same thing here, I'm going to get x equals 3. And here I get x squared equals 0. Take the square root. Well, the square root of 0 is plus or minus 0. And plus or minus 0 is just what? 0. So there's my zeros. But you have to do one more thing with these zeros. You have to write their multiplicity. Well, if you look at the factors, what was the power of this factor? It was a power of 1. So this has a multiplicity of 1. This was a power of 1, so it has a multiplicity of 1. This had a power of 2, so it has a multiplicity of 2. Why is that important? Well, because of lack of room on this paper, I'm going to sketch this on a different sheet. And I'm going to keep the zeros and multiplicity showing. Try to anyway. And the first thing I do is just say, okay, well, I've got an x and a y axis here. There's y. And there's x. And I say to myself, okay, well, what were my zeros? My zeros were 0, 3, and 1. So I make a point at 0, I make a point at 1, and I make a point at 3. Okay? And I know that the ends have to be going up. I don't have a choice. That's the end behavior of the polynomial. Okay, if we zoom back out a little bit and show you that. Remember, I showed you the end behavior because it is even and positive. So now, the last thing is this. This had a multiplicity of 1, and that means that this polynomial must go through. Okay? This had a multiplicity of 1, so that means the polynomial must go through. This had a multiplicity of 2, which means the polynomial will bounce. We call that a bounce. Okay? And so there is my sketch. And if you notice, this going through, and this bouncing creates the correct end behavior for this polynomial. So this is the sketch for problem number 1. Okay? So just a very, very simple sketch. So now we're going to work on problem number 2. Problem number 2, very similar to problem number 1, is this jumbled mess that is not factored. And the first thing I noticed is it is negative and odd. So the end behavior will be down from left to right. So the left end will be up and the right end will be down, and I have no idea what will happen in the middle, okay? So that's the first thing I notice. The second thing is the Y-intercept. I need to find the Y-intercept, okay? How do I find the Y-intercept? I set x equal to 0. So I have 0 plus 0 plus 0 minus 72. Well, 0 plus 0 plus 0 minus 72 gives me the point 0, 72. And since it's minus 72, right, 0 plus 0 plus 0 minus 72 will give me negative 72. Okay? So I know the end behavior, I know the Y-intercept. Now I need to find the X-intercepts. Well, how in the world do I find the X-intercepts? Okay? Well, the simplest, easiest, smartest thing for me to do is to factor this thing. And I look and I say, well, I notice that 2 will go into all of these things. So I say, okay, well, can I factor out something like maybe a negative 2? Can I factor out a negative 2? Would that work? So let's do that. If I factor out a negative 2, what am I left with? I'm left with 3x cubed plus minus 4x squared minus, and 54 divided by 2 is 27, and then 72 divided by 2 is 36, and all of the signs change. Now, if I do that, what have I got left? What else can I do? Well, I still have a 4-term polynomial, and the easiest way to factor a 4-term polynomial is by grouping. So I take this polynomial and I say, okay, 3x cubed minus 4x squared minus 27x plus 36, and I factor this end, which is going to give me x squared times 3x minus 4. And my goal over here is to get this same term in parentheses. So I want to get 3x minus 4. Well, to get that, I'm going to have to factor out a negative number. And what will give me, what times 3 will give me 27, what times 4 will give me 36? And the answer is 9. 9 times 3 is 27, 9 times 4 is 36. So now what are my factors? Well, my factors are x squared minus 9 times 3x minus 4. And remember, when you factor by grouping, one factor will be the common term, the other factor will be the individual terms. Okay? Well, that's good. This will factor again. So when that factors again, what do I get? Well, this is a difference of squares, so I get x plus 3 times x minus 3 times 3x minus 4. And so now, given this, I have these three factors. The multiplicity is 1, the multiplicity is 1, and the multiplicity is 1. And I ask you, what solutions do these give me? Well, this one's easy. You just move it over. You get x plus 3 equals 0. You move it over, you get negative 3. This is x minus 3 equals 0. You move it over, you get x equals positive 3. This one you may want to write out. Okay? You get 3x minus 4 equals 0, which is 3x equals 4, which is x equals 4/3. Okay? And that's just move this over and then divide by 3. So, comma 4/3. Okay, so I know my zeros. And each one has a multiplicity of 1. Okay? And I know my Y-intercept. And I know my end behavior. So I have to translate those three items into a graph on a clean sheet of paper. So I'm going to take a clean sheet of paper. Zoom out just a little bit here. Here's a clean sheet of paper. And I'm going to say, okay, you want me to sketch this? I can do that. Now, First step in sketching this is going to be, where were the zeros? Well, the zeros were at -3, 3, and 4/3. Okay? The y-intercept was at -72. And the end behavior is going to be up and down. So what does that mean for me? Well, this is going to come in and go through that 0 because it had a multiplicity of 1. It's going to hit the y-intercept. It's going to go through that 0 because it also had a multiplicity of 1. And it is going to go through that 0 because it also has a multiplicity of 1. And lo and behold, I was able to connect my ends, and there is my sketch. And the important thing to remember here, folks, is this is a sketch. It is a quick way to look at what will this polynomial look like. Okay? So that sketch goes with this second polynomial. Okay? Zeros at -3, 3, and 4/3. Okay. Now, last and certainly not least is the third equation on my paper here. H of x equals -2x. Now, something different I noticed here. This is already factored for me. And I look, the leading term is negative. And the power to this is 1 plus 3 plus 2. Well, 1 plus 3 plus 2, that totals to 6. So it is even and negative. Okay, even and negative. What that means is the end behavior will look like this. Both ends must point down. It's an even power with a negative leading coefficient. The ends must point down. Second thing I do is I say, well, what about the y-intercept? Well, how do you find the y-intercept? You set x equal to 0. So how do you find the y-intercept? Set x equal to 0. So if 0 times, and it doesn't matter because 0 minus 3 is -3, -3 squared, -3 cubed is a big old number, it's 27, but 0 times anything is 0. So where's the y-intercept? 0, 0. Let me say that again. When I put 0 here, 0 times anything, no matter what I get out of here, 0 times anything is 0. So I don't even have to work this. Once I plug in 0 here, I'm done. It's just 0. Okay, so I know my end behavior. I know my y-intercept. Last step is to find my zeros. Well, somebody already factored this for me because they're very nice. So I get -2x equals 0. I get x minus 3 equals 0. And I get x plus 5 equals 0. Well, this is going to give me x equals -5. This is going to give me x equals 3. And this, if I divide by -2, is going to give me x equals 0. So here are my zeros. But I also have to write the multiplicity. What is the power of this? 1. What is the power of this? 3. What is the power of this? 2. So there's your zeros and your multiplicity, along with your end behavior and your y-intercept. So if you know the zeros, the multiplicity, the end behavior, and the y-intercept, you can sketch any polynomial. So let's sketch this polynomial. Now, this one may be a little trickier. We'll see. So I take my paper and I say, okay, x-axis and y-axis. And I know I have a y-intercept at 0. I have a 0 at 3. And I have a 0 at -5. And I know the end behavior is downward. Now, here's the fun part. A single root, which is this one, has to go through. A double root, which is -5. -5 has a multiplicity of 2. We already learned that multiplicity of 2 will always bounce. Okay? So multiplicity of 2 will bounce. A multiplicity of 1 will always go through. Now, here's the thing about a multiplicity of 3 that I want you to understand. Multiplicity of 3 is called a tangent. Okay, it's called a tangent. And when you have a multiplicity of 3, you have two choices. It can either go like so, or it can go like so. Okay? And this behavior is basically determined by your end behavior. Well, if I look at this 3, it's either going to go through and flatten out and go down, or it's going to come down here and flatten out and go back up. Well, I know the end behavior has to be down. So to finish this graph, this has to flatten out and go down. Okay? And so there is a nice, neat sketch, or as neat as you're going to get from me, of the graph given by this third equation, h of x. Okay? So this is kind of how you do this. And in algebra, we talk about end behavior, and we talk about multiplicity and zeros. And this is where all of this comes in, is to be able to sketch this polynomial without plotting 100 points. And this gives us a basic shape, and then we can plot a few points to refine that shape. So if you have any questions about this, please come see me.